Assalamu alaikum. How are you? Hope you are well by the grace of Allah. And if Allah helps you, Allah keeps you free from all kinds of difficulties as well as outbreak prevailing now. And it is also hope that you are maintaining health rules given by WHO or our local doctors. And this is Kamul Hassan. Welcome you all in this class. At first, we will discuss today's learning outcome will be elasticity, strain, stress, Hooke's law, and Young's modulus. By turn, I will discuss about the matter. And at first, what is remaining here? This is elasticity. And before the discussion of elasticity, I would like to discuss about a term that is deformation. Because this deformation, this word will come in every case of these topics. What is deformations? Many of you have elongated a spring or wire by pulling on it and releasing. And in physics, the pulling of a body is called applying force, and if you pull something, then its length or shape must be changed. So change of length is called deformations. So you can easily understand that deformation means to change a body by applying force. So the deformations, as it comes in every human, so we should have this idea about deformations. Now we can easily understand what is called elasticity. When force is applied, let's write this word elasticity. First one, elasticity. How can we define this? When a force is applied on a body, then deformation occurs, and due to these deformations, the body a counter force also created. When the force is withdrawn, then the body comes back to its original position. Then this is the elasticity. So we can define this word elasticity as the properties for which a body comes back to its original size or main size is called elasticity. Now, what is called strain? This is the, I think you have good idea, you have got the point about this word elasticity. Now comes to the point strain. Number 2, strain. Actually, it is the relative change in length or shape. I repeat, strain. This is the relative change in shape or length due to which is made by force from outside. If force is applied on a body of length L0, and if it is elongated length if L, then what is the strain? We get strain equal to L minus L0 divided by L0. That is the, we apply force on a body of length L0, and after the application of force, if the length of the body is L, then we got the strain as L minus L0 divided by L0. That is the, in upper position, this is the length of after increasing, and this L0 is the length of original previous shape, and L0, that is the initial stage. So this is the difference of final length and initial length divided by initial length. This is the strain. Now come back to the point stress. Number 3, we know the point stress. What is called stress? Stress is the force per unit area that develops inside a body due to deformation. Let me write here. Stress is the force per unit area, that develops within substance within substance due to deformation. Deformation. If force is applied on a body of cross-section area A, then this body, inside the body, there creates a resistive force. If the resistive force is F, then stress will be F by A. And from the previous class, from pressure, P equal to F by A. So here the stress, as stress is F by A, so its unit is also Pascal. Stop. Dear students, already you have known about the topics elasticity, strain, stress. Now let me start on topic Hooke's law. How can we derive Hooke's law, or what is called Hooke's law? Let me write here Hooke's law. Please pay me attention. In this case, Hooke's law. And what is said by Hooke's law? Within elastic limit, the stress is directly proportional to strain. Right here, within elastic limit, the stress is directly proportional to strain. If you write this in this way, that is stress equal to that is stress proportional to strain, or we can write this formula like this: stress equal to, if we replace this proportional, we can write stress equal to constant into strain. By replacing this proportional, we can write a constant, and this constant is called modulus of elasticity. This constant is called modulus of elasticity. Okay. Dear students, now we would like to discuss about Young's modulus, and on discussing this, we should look at the figure. Some figures are here. Young's modulus. Suppose draw some figure here. This is a figure. This is the length. Think about a wire, and the length of wire is L0. Suppose it, and in this case we have to think about wire of fixed length, and also we should think about the weight. And now if we draw another wire, that is here, if we hang a body of weight W, then it must be lengthened, and its length will be L, and here we hanged a body of weight W, and in this case the tension or resistive force that creates on upward, it will be T. So from this figure we can understand about Young's modulus. Let us suppose now at something Young's modulus. Let us suppose that a wire of cross-sectional area, it was of cross-sectional area A is, that is where the length, suppose that the length of length, here is length, dear students, look at the board. Please look at the board. Let us suppose the length of a wire of cross-sectional area is L0. We think it, this is the length. We think about a wire of length L0 and its cross-sectional area is A. Now, a body L0. Now, a body of weight W is hanged. This is the original wire. Now, a body of W is hanged from it. So, as you are hanged a weight W, so obviously the length of this wire will be changed and it will be increased. Now, the elongated, so we can write that the elongated area, elongated length is L. This is the L after pulling the weight. This is the elongated L. So this elongated length will create a counter force. Elongated length creates a counter force that is acted upward. And from the figure you can see that upward, and its name is tension. You can see from the body original length and length after pulling the weight. Then when the weight is hanged, then a resistive force or counter force is created and this acted upward and this is called tension. So from the definition of strain, we can write here from this figure we can write strain is L minus L0 by L. Strain, then what will be the stress? And stress will be T by A. You know from the stress, from the definition of stress, that resistive force per unit area, and here is tension divided by area. This is the stress, and strain is L minus L0 divided by L, and stress equal to T by A. And from this figure we can write that T by A equal to L minus L0 by L. Hooke's law, we write this or stop. Dear students, actually here it will be L0, that is difference of changed length minus changed length and original length divided by original length. And here stress will be T by A, and T by A, this is actually proportional to strain. You know from Hooke's law, stress is proportional to strain, or we write this formula in this way: T by A, by replacing proportional sign we write T by A equal to constant into this strain, and here what we write this constant, and here T by A or T by A equal to constant into strain, that is T by equal to constant L minus L0 by L0, we write the previous thing, and this constant is called modulus, Young's modulus. This constant is called Young's modulus. This call is Young's modulus. And dear students, these are the topics that we have discussed in the class, and in this class we will try to solve some problems relating on the topics, and I hope that you have understand the topic that I have discussed here. And when we come once again, we will also discuss some creative questions over the topics, and till then, Allah Hafiz.